right, have your homework out and books open to page 123. But before we begin, I want to kind of review over what we were doing in the homework, what we were doing in our last lesson. And basically, we were going to rewrite angles as sums and differences, like we would do, for instance, with something like 165. We would say, well, that's 120 plus 45. And you kind of had to figure out what angles to use. Well, what we're doing now, where we're instructed to rewrite this as, for instance, the same function of a positive acute angle, you don't have to wonder what angle to use. Same functions always use either 180 degrees or 360 degrees, whichever one is closer to the angle in question. So here, we would rewrite our 148, and we would start, if it says same function, with one of these angles. Well, obviously, which one's closer? 180 degrees. And to get from 180 to 148, we have to add or subtract. How much? 32 degrees. And since it said same function, since we used 180, we keep the same function, secant, and the other angle is telling us exactly what angle we need. And then we just ASTC, quadrant 2, secant is, so we stick a negative on the front, we're done. But had it said to rewrite in terms of the cofunction, we would not use 180 or 360 class. We would use either 90 degrees or 270 degrees, whichever one's closer. Well, which one's closer to 148?
270. Well,
90 is closer. So we're going to rewrite this as the secant of 90 degrees plus or minus plus 58 degrees. And then since it said cofunction, and since we used a 90-degree angle, we write the cofunction. And we write down the angle. And ASTC, we keep a, and we're done. That's all we're doing. Rewriting in terms of same function or cofunction, but we're taking shortcuts. Same function, we rewrite based off of 180 or 360. Cofunction off of 90 or 270. Whatever angle is listed second is the angle that we keep. And then if it's 180 or 360, same function. 90 or 270, cofunction. But go back to the original for your ASTC. So let's look at another. Suppose we have the tangent of 312, and now we're asked to rewrite in terms of the same function. What angle should I use if I want the same function class?
360.
In this case, 360 is closer than 180. So I'm going to write the tangent of, start with the quadrantal. 360 plus or minus? Minus 48 degrees. And since it's 360, at x-axis we keep the same function. We keep the new angle. And ASTC in quadrant 4, negative. But had it said cofunction, we would not have started with 360 class. We'd have started with 270. And we'd have written the tangent of 270 degrees plus or minus plus 42. And so since we went off the 270, the y-axis, it also said cofunction, we're going to write not tangent, but cotangent of the 42 degree angle and ASTC, quadrant 4, negative. We're done.
These are easy, it's just a pi.
Does it make sense? Now again, radians do make things a little more miserable, I'll give you that. Yes, that's true. But this is basically the process. So if we had the cosine of 275 and we wanted the same function, then I would rewrite my 275 degrees as
360 minus 85.
So then we write,
Cosine 85.
and this is in quadrant 4, so there we go. But had it said cofunction, I would not have written 360 minus 85, because I would have written 270 plus 5. So I would get cofunction, sine of 5 degrees, and ASTC, positive. You go off of what's given, the given function, given quadrant. That's what tells you what to get for your answer. There we go. Making sense? Let's look at the homework now, and let's see if maybe, now that we have a little better understanding of how to work these problems in general, make sure we can overcome the radian struggle that exists. Radians are annoying, aren't they?
Yeah.
Whoever knew pi could be annoying. I always thought pi was delicious, but in pre-calculus, pi is annoying, which is why when we get done with pi,
When is
make
Pi
it
Day?
delicious. Pi Day's March 14th.
Oh my goodness.
March 14th. So you got a little while to wait. By then you will have felt like you earned your pi. You still haven't earned it all yet. All right, so number 13. No, you think you have. You do not know. Cosine of 265 degrees. And it wants same function. So what do we do, Quentin?
Cosine 180 plus 85.
So it becomes
Cosine 80. Yes. Or 85 again.
and quadrant.
3. So negative.
We're done. Looking at number 15, we got the cotangent of 5 pi over 4. Same function. But since it's in quadrant, Jamie, 3, we don't put 180, we put pi. So I'm going to rewrite this as the cotangent of pi.
Minus pi over 4?
Well, remember, this is 4/4. I would subtract 1 pi over 4 to get to 5/4.
Would be
If I have 4/4, I would need to add 1/4. Does that make sense? All right, so what do I get?
you look at the cotangent of pi over 4, and because it's in quadrant 3, it would be positive.
There we go. There's our answer. Number 17, we have the cosecant of 7 pi over 6. It says same function, Ethan.
Cosecant, and then so pi plus 1 pi over 6.
There we go. Think of it as 6/6. You add a pi over 6. So,
Cosecant pi over 6.
and it's in quadrant 3 because you had to go from pi and add a little bit. Negative cosecant pi over 6. Number 19, we have the secant of 5 pi over 3. So, let's see, what quadrant is this in, by the way, Quentin?
3. No.
3/3?
It's quadrant 4.
Or 6/3?
4.
It's closer to 6/3. This is quadrant 4. So I'm going to start with the closer one, the 6/3 of a pi.
Minus pi over 3.
So, same function.
Secant pi over 3. Positive.
There we go. Looking at number 21, we have the cotangent of 290 degrees. Jamie.
You would have cotangent and be 180 minus 110.
Minus 110?
So
Well, if I subtract 110, that would equal 70.
it would be add.
Plus 110. But here's the bigger problem. This needs to be acute. Remember, you're going off of either 180 or 360. Which one is 290 closer to? It's closer to the 360, isn't it? So instead, let's start with the x-axis angle, x-axis quadrantal it's closer to. Let's write instead as 360 minus...
Minus 290 would be 70.
Minus 70. 360 minus 70 is equal to the 290. And then from here, since it's same function, since I'm basing it off the x-axis,
It's just cotangent and 70 degrees, and because it's quadrant 4, it would be negative.
there we go. And the last one, number 23, we have the cosecant of 320 degrees. And Ethan, how do we rewrite 320?
360 plus 40.
Plus?
Minus 40.
There we go. Say 360 plus 40 would be 400. 360 minus 40 is 320. So we get?
Negative cosecant 40.
Good. Cosecant of 40, but it's negative because in quadrant 4, cosecant's negative. All right. I'm not so much going to ask how you did on the homework as much as do you feel like you've got it now? Anytime it says same function, you're either going to go off of 180 or 360 for your first angle, or off of pi or 2 pi. You're going off the x-axis for your lead angle, and you add whatever it takes or subtract whatever it takes to equal the angle you are given. That same function, the next set of problems from the homework, which was 29 to 41, the odd, were cofunction. We don't go off the x-axis for cofunction class, we go off the
Y.
So that means either
90 or 270?
90 degrees or 270 degrees, or in terms of radians,
Pi over 2 or 3 pi over 2.
whichever one is closer to the original given angle. So we look at numero 29. We have the cosecant of 95 degrees. Obviously, which angle is closer to it, Chris?
90?
90. So I'm just going to rewrite my 95 degrees as a sum or difference. 90 degrees
Minus 5.
minus 5 gives 95?
Oh, plus 5.
Plus 5.
Yeah.
We just make it add together or subtract together. In this case, add together to equal
So
that.
it doesn't matter if 5 is in a special angle?
Not for what we're doing right now, because we're just rewriting. Yep. So we're starting with a quadrantal and plus 5. Now, anytime we go off of the y-axis class, that changes the function to its cofunction. So instead of cosecant class, secant. And then we're going to keep the second angle. Never the quadrantal, always the second angle. Last step, remember, what quadrant are we in?
That's second quadrant.
And cosecant in quadrant 2 is?
Positive.
So my answer is also going to be positive. Looking at number 31, we have the cosine of 265 degrees. Again, if we're changing to the cofunction, we're going to go off the y-axis, either 90 or 270. Obviously, which one's closer, Jamie?
The 270.
So I'm going to rewrite 265 degrees as,
270 minus 5.
right, 270 degrees minus 5 degrees. And so since I went off the y-axis, my cosine changes to the cofunction.
Sine.
And I keep the second angle.
5 degrees.
And quadrant
3.
3, ASTC,
It's negative.
it's going to be a negative, sine of 5 degrees. Looking at number 33, radians, just roll with it. Okay, we got a 7 pi over 6. Is that closer to half of a pi or 1.5 pies? Quentin?
1.5.
Closer to 1.5 pies. So I'm going to rewrite my 7 pi over 6. Let's change this to have a denominator 6. Multiply top and bottom by 3. So this becomes 9 pi over 6. How do I go from a 9 pi over 6 starting angle to 7 pi over 6?
Minus 2 pi over 2.
There we go. And since I went off of the y-axis class, I don't write cotangent,
And
tangent. And I would write 2 pi over 6, but I'm going to reduce that.
pi over 2.
And quadrant
3.
3, ASTC,
Positive.
keep the positive. And there we go on that. Let's do
It's really easy.
really easy, super easy,
It's
stupid
gonna-
easy.
But I'm assuming we're going to build on that too.
Oh yeah, 5 cosecant 5 pi over 4. Again, I'm doing cofunction per the directions, so I can't start at pi. I've got to start at either half of a pi or 1.5 pies. Which one's closer, Ethan?
1.5 pi.
But I want the same denominator as here. So instead of a 2, I want a denominator of 4. So I'm not going to write 3 pi over 2. Rather, I'm going to write
12 pi over 4.
multiply top and bottom by 2.
Oh yeah. So 6 pi over 4.
6 pi over 4. Now, how do I go from a 6 pi over 4 and equal to 5 pi over 4?
Minus pi over 4.
There we go. I'm rewriting 5 pi over 4 as a sum or difference. In this case, a difference that involves a quadrantal. And so since the quadrantal comes off the y-axis, I don't keep cosecant. If it came off the x-axis, I would. It comes off the y-axis. So I change to
Secant.
secant. I keep the,
Pi over 4.
since it's already reduced. And then quadrant
3.
3, because again, you're starting at 270 and working backward into the third quadrant, I would keep a negative.
So how
And
would
there's my
you
answer.
know if it's in the y-axis or the x-axis?
If it tells you cofunction, you go off the y-axis. If it tells you same function, you go off the x-axis.
Okay. I didn't know if it was like...
Yeah, you want to go back and watch yesterday's
Yeah, I
lesson.
will.
And that'll help tremendously. After the quiz, so right around the 30-minute mark. So there's only like about 20 minutes of video for you to watch. But yeah, watch that, and then I would say watch the first like 10 minutes of this lesson, and you'll be right with us. All right, where did we leave off? That was number 35, 37. We have the secant. of
How many
11
did you
pi.
get last night?
Huh?
How many did you get last night?
They did about a dozen
41.
problems-ish. Well, you only did the odd problems. You make it sound so awful. Let's see,
13.
6, there's about a dozen problems.
13.
Lucky number. All right, so we have
I was
secant
thinking
11
the
pi
same
over
thing.
6. And Chris, it says cofunction. So I can't go off the x-axis. I can't go off 180, 360. I can't go off a pi or 2 pi. I got to go off either 90 or 270 or pi over 2 and 3 pi over 2. Which is that closer to? 90 or 270? Pi over 2 or 3 pi over 2?
Pi over 2.
3 pi over 2. So I'm going to rewrite it. My first angle in the sum or difference is always going to be the quadrantal, but I'm not going to actually write 3 pi over 2.
9 pi over 6.
I'm going to multiply top and bottom by 3 to get 9 pi over 6. And how do I rewrite 11 pi over 6 if I start with a 9 pi over 6?
2 pi over 6.
Plus 2 more pi over 6. And since I went off the y-axis, which I did because it said cofunction, I'm not going to write secant,
You're going to write cosecant.
and I'm going to write which angle?
The 2 pi over 6, but you're going to reduce it pi over
And then finally, this is evidently in quadrant
3.
4, so I'm going to use what? SIGN.
Negative.
Ooh, ASTC?
Positive.
Positive. This is cosine's quadrant. Secant goes with cosine. Positive. Cosecant pi over 3. Numero 39.
Wait, that says cosecant.
Yeah.
I thought I said.
No, we're going off the given. The given is secant,
Yeah.
and quadrant 4 is positive. So that's why we go with
I
positive.
said cosine. I didn't say cosecant. That's why I was confused.
Oh, well, I gave you credit for being smarter than you were. All right.
We love that.
Let's go to the next one here. We have the cotangent of 320 degrees. Quentin, it wants the cofunction. So I am going to write the 320 degrees as a sum or difference.
270 plus 50.
270 plus 50. So then I go from cotangent to
Tangent 50. That's quadrant. So negative.
negative because it's in quadrant 4, and cotangent in quadrant 4 is negative. And the last one we have is the cosecant of 290 degrees, Ethan. Again, cofunction, go off the y-axis, rewrite 290 as
270 plus 20. And then secant plus, or secant 20. We're in quadrant 3 or 4. It's positive. No, it's negative.
negative. Cosine is positive,
Yeah, I'll
cosecant
take
is
the
negative.
cosine.
And there's our answer. All right. Did anyone get these?
I got some of them.
Some of them?
About
All right.
yeah,
So we weren't totally lost last
I got
time.
If I would have watched the video, I would have got all these.
All right. Do we feel like we understand it now at least?
Mhm.
All right. I want you to go back and do 14 to 22 to even. Now, all of these are same function. So we ain't using the y-axis. We're on page 123. We're not using y-axis for same function class. We use the x-axis. 14 to 22 to even. Go off the x-axis. Rewrite in terms of the same function. Expression in their poem
Why
recitation.
do you put in radians for
X-axis?
yeah
What angle's that?
180
What's that?
360?
There we go.
In radians, what's that?
In radians, what's that?
Pi.
Pi, what's that?
2 pi.
2 pi. Is that what he asked for, was radians?
I don't know. I have no idea.
Like I wasn't listening. I'm a slob. You slob. Squealing children. Not a fan.
Sure, Essie doesn't kill one.
Not squealing ones anyway. Heard the joke, what's louder than a squealing pig caught under a fence?
What we just heard downstairs.
Nope. 2 squealing pigs caught under a fence.
Oh.
I didn't say it was a good joke, I just asked if you'd heard the joke.
What's louder than one squealing kid stuck under a fence?
Chris is beating behind.
Oh my.
Oh yeah.
You said it.
Is that my quiz?
It is.
Oh.
All right, let's go. Number 14.
Let's go.
We need to rewrite tangent of 245 in such a way as to rewrite as the same function of a positive acute angle twinting.
Tangent 180 was 65.
Good. Start with the quadrantal 180. You have to add 65 to equal 245, so it becomes
Tangent 65.
positive or negative,
Positive.
because it's in quadrant 3. How many have this for the first one? Looking at the next one, number 16, we have the secant of 4 pi over 3. Jamie, how do I need to rewrite this to get the same function?
Pi plus pi over 3.
Pi, or 3 pi over 3, plus pi over 3. So it becomes
The secant of pi over 3 and
positive or negative?
is negative.
Negative, because it's in the third quadrant. How many have that for number 16? On number 18, we have the sine of 11 pi over 6. Ethan, how have we got to rewrite that?
We have to rewrite that sine 4 pi over 6 minus pi over 6.
Good. 2 pi, or 12 pi over 6, minus pi over 6. So this becomes,
Sine pi over 6 negative.
and it becomes a negative. I'm going to have that for number 18. Number 20, Christopher, we have the tangent of 7 pi over 4. How do I rewrite that?
I wrote it as 14 pi over 8.
14 pi over 8.
14 pi over 4, sorry.
14 pi over
You
4.
have to double it for 2 pi.
The bottom.
Okay. All right. Well, let's do this. Let's just say 2 pi minus something. And what denominator does this need to have?
4.
So I want an 8 pi over
8 pi
4
over 4.
minus something. What do I have to subtract from 8 pi over 4?
1 pi
to
over
get 7?
4.
1 pi over 4. Does that make sense?
Yep.
That's all it is. You rewrite the 2 pi over the 1 pi, or the pi over 2 over the 3 pi over 2, so it has the same denominator. And now what do I get?
Tangent of negative, or no, tangent of pi over 4. You're in quadrant 4, tangent is negative.
So there's my answer. How many have that on number 20?
I had that. I don't know how I got that because I did something completely different, but I got that.
Yeah, don't do different, do that. Number 22, let's stay with Chris. We have the cosine of 345 degrees. How should I rewrite that?
Cosine 360 minus 15.
So I get
Cosecant of 15.
cosecant.
Cosine of 15.
Cosine of 15, positive or negative?
Negative. It's in the fourth quadrant.
ASTC. Positive. Positive cosine 15 degrees. All right. Anyone go 5 for 5? Anyone 5 for 5? All right. Questions?
I went 4.
Again,
4 or 5.
If you go back and watch the video, you'll have it much better.
I went 3 for 5 because I didn't put the I didn't get the right sign.
Oh.
Is that all points off?
I don't know. All right, do 32 to 40 now. 32 to 40 even. This time you're doing cofunction. So do I care about the x-axis?
9.
Not on cofunction. I care about
No.
y-axis. Everything goes off the y-axis for cofunctions.
Are you sure about that?
I am.
Are you Jedi?
Even?
Yes.
32 to 40 even. I didn't cross out even. I left even up there. I just crossed out 14 to 22.
the important points are 3 pi over 2 and half pi. So 1 over pi, or
1 pi over 2 and 3 pi over 2. Let's take a look at these evens here. Number 32, we got the tangent of 220. And Ethan, since we're going cofunction, I got a running through off a 90 or 270. Obviously, the closer one is
90, 270.
270. So I'm going to write this as 270.
Minus 50.
And what does that become?
Cotangent 50 positive.
Good. Cotangent 50, and it's a positive cotangent 50 in the third quadrant. Number 34, we have the secant of 4 pi over 3. Jamie, I need to rewrite this as?
Pi over 2.
Well, is this closer to pi over 2 or 3 pi over 2?
3 pi over 2.
It's closer to 3 pi over 2. So I'm going to start with the 3 pi over 2, but I can't, it's really hard because I don't have a common
Denominator.
So let's kind of morph this into having a common denominator of 6. This would become 8 pi over 6, right? And I'm also going to rewrite this. So instead of 3 pi over 2, I'm going to have
9 pi over 6.
9 pi over 6. Okay, so I'm trying to go from a 9 pi over 6 quadrantal to an 8 pi over 6.
You minus 1. So it'd be pi over 6. And then you just have secant.
Well, going off the y-axis, so
Cosecant pi over 6. Because it's quadrant 3, it would be negative.
there we go. Does that make sense on the common denominator thing? Okay. It happens more often with the y-axis, cofunctions, than it does with the x-axis. Number 36, we have the sine of 5 pi over 3. It's pretty much the same thing going to happen again. Because once again, Quentin, which of the y-axis angles is that closest to?
3 pi over 2.
It's closest to the 3 pi over 2. So normally I would start with a 3 pi over 2, but not this time. Instead, I'm going to make this sine of
10 pi over 6.
I'm going to rewrite this as the sine of
9 pi over 6 plus pi over 6.
So
Cosine pi over 6. Negative.
And negative, because in the fourth quadrant the sine is negative. Questions on that one? Look at the next one, which is number 38. We have the tangent of 7 pi over 4. And Chris, which is this closer to, pi over 2 or 3 pi over 2?
3 pi over 2.
Once again, closer to 3 pi over 2. So we're going to start with the
6 pi over 4.
Yeah, here we already have a denominator we can work with. We don't have to change both of them to 6's. I can just change this one to a 4. 6 pi over 4, all I have to do is
Pi over 4.
add another pi over 4. So,
Positive cotangent pi over 4.
you're right about the cotangent pi over 4. What quadrant would this be? If you go to 3 pi over 2 and you add a little bit more. It goes into the 4th quadrant where tangent is negative. So, negative cotangent of pi over 4. Number 40 was the last one. We had the cosine of 345. And Chris said he wanted to do this one. So Chris,
360.
Cofunction, same function. You can use 360. You can't use 360. 270.
So you have 75. So you would have cosine.
Cofunction.
Sine of 75. You're in the 4th quadrant. Sine is negative.
What's given is cosine. Positive. You go off what's given to you. And there we go. Questions on this?
Did you already go over the quizzes?
Not yet. Oh, there are quizzes. Yeah, I already passed them back before we started the video. All right, let's go ahead and turn the page now. And let's take a look at another way in which we will use these. We can use these cofunction things to simplify sums and difference identities if they are based off of quadrantals. Now again, normally you see sum or difference identity, it's sine, cosine, cosine, sine, cosine, cosine, sine, 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 right? But if one of the angles is a quadrantal, we can either do same function or cofunction, depending on what the starting angle is. Look, for instance, at 43, copy it down, you'll do this with me. We're given the cotangent of pi over 2 minus lambda times the tangent of 3 pi over 2 plus lambda minus the cotangent of 3 pi over 2 minus lambda times the cotangent of pi plus lambda. Can you imagine if I had to do tangent plus minus tangent all over 1 minus tangent tangent, and then 1 minus tangent tangent all over tangent plus minus tangent over and over and over again? That'd just be ghastly. But notice, every one of these begins with a quadrantal. So what I typically do first is I think quadrants first. Okay, to me that's going to be the best approach. Pi over 2 is here, but I'm subtracting something. So that puts me into quadrant 1. Here I'm at 3 pi over 2, and I'm adding more to it.
4.
Here I'm at 3 pi over 2, but I'm subtracting something away.
3.
And here I'm at pi, and I'm adding something to it.
3.
Quadrant 3. Do you see how to visualize the quadrantal and either make the angle bigger into the next quadrant or smaller back into the previous? Does that make sense? How to figure out quadrants. Now what I do is I go through and I say same function or cofunction. Right here, class, we have cofunction. It's off the y-axis, so I'm going to not write cotangent. I'm going to write tangent of the second angle, which is lambda. And in quadrant 1, positive. Right here, same function or cofunction? Cofunction. So I'm going to write of, and in quadrant 4, negative, ASTC. Then I'm going to keep my minus sign. All right, same function or cofunction? So not cotangent, no, no, no. Tangent of lambda, quadrant 3, positive. Same function or cofunction? Same function, so keep your of quadrant 3, positive. See how we did that? That's so much faster than tangent plus minus tangent all over 1 minus plus tangent tangent, isn't it? If one of the angles is a quadrantal, you just ask yourself same function or cofunction. Now, if I multiply positive times negative, I get a negative. And I can rewrite the cotangent as 1 over the tangent of lambda. Here I've got minus a positive positive, so just...
Wait, how'd you... Oh, because it's reciprocal.
Here I've got negative, positive, positive.
Negative.
Negative. And I've got tangent times, and again, cotangent can be written 1 over the tangent of lambda. Well, thoughts on the tangent lambda and tangent lambda, numerator, denominator? So all of this just becomes negative 1. Here again, we got a tangent and a tangent. To get negative 1. Negative 1, negative 1, negative 2. What this means is, if you take the cotangent of 90 minus any angle, multiply by the tangent of 3 pi over 2 plus that same angle, minus the cotangent of 3 pi over 2 minus that same angle, times the cotangent of pi plus that same angle, it'll always equal negative 2 no matter what the angle is. Couldn't you imagine a verification saying equals negative 2? And I just make this side match a negative 2.
I'll kill myself.
Oh, don't do that, because it's a coming. If you look further down the page, it's say number 54. That one's a dilly. Can't wait for number 54. We're going to do that one, don't worry.
Today?
Not today. No, not today. No, you're not ready for it yet. We're going to get there. We're going to work our way slowly.
You're ready for it.
No, you're not ready for it. All right. Not ready for the training? No.
I see much darkness in this one.
All right. Fear. All right. Way too much. I have a Star Wars board up right now. You wouldn't know because that's for physics, and so you don't get to see it in pre-calculus.
Loser.
Anyway, in the physics videos, whenever they get recorded, maybe it'll show up. We'll see. All right. Let's take a look at number 45. Copy it down. Numero 45. Oh, copy it down.
Ethan's favorite song.
Oh, yeah.
We have a chi or a chi, depending on which way you want to pronounce it. Everybody say chi. Chi. Huh. Very photogenic. All right, now my turn to copy it down now that y'all are done. We have a cosine of chi minus 90 degrees. Hey, degrees instead of radians, this is wonderful. Times the sine of negative pi plus chi minus the sine of chi minus 3 pi over 2 times the sine of chi minus pi over 2. All right, I want you to write this down in your notes. You gotta have the quadrantal first. Put the quadrantal first. So the 90, 180, 270, 360, put it at the front of the angle. And for these, there's only one that has the quadrantal first. That's the second one. All the rest of them, they out of order. So we're gonna fix it. We're gonna make this the cosine of negative 90 plus chi times the sine of negative pi plus chi minus the sine of negative 3 pi over 2 plus chi times the sine of negative pi over 2 plus chi. Get the quadrantal into front, because that's how we've been doing it this whole time. Why would we change now? And you can't really determine the quadrant without it, because we don't do negative angles much here. Here we got all these angles negative, right? So what do? Well, factor out the negative. I want you to do this with me. This becomes the cosine of negative 90 minus chi. Then this becomes the sine of negative pi minus chi. You following what we're doing? Finish out the step. Because we don't do negative quadrantals. That's annoying. I don't want to have to think of negative 90 or negative 180 or negative 270. No. Let's just factor out the negative. Especially since, class, we have negative angle identities. That tells me exactly what to do if the angle as a collective whole is negative. Anytime you work with cosine and the angle as a collective whole is negative, what happens to my negative? Vanishes. Poof. It's just cosine of 90 minus chi. What happens with the sine if you have a negative angle? It goes to the front. It becomes the negative sine pi minus chi. And that's going to happen 3 more times, isn't it? Negative sine of 3 pi over 2 minus chi. Negative sine of pi over 2 minus chi. This one is really obnoxious. This is about as obnoxious as it can get because every single one almost was out of order. Then every single one led with a negative quadrantal angle that had to be factored out. So there's a lot of negativity that has to be dealt with here. But we dealt with it appropriately, I would say, right? Now we can go about our business. Now we can do what we started with last time. Let's figure out what quadrant we're in. 90 minus something will put us into quadrant.
1.
Pi minus something will put us into quadrant.
2.
3 pi over 2 minus something puts us in quadrant.
3.
And pi over 2 minus something puts us in quadrant 1. So we have quadrants 1, 2, 3, and 1 respectively. Let me move this out of the way because we're going to keep working our way down this chalkboard here. All right. Now we ask ourselves, I told you it was annoying. There's a ton of stuff to do right at the beginning. All right, now I ask myself, 90 degrees, that's y-axis. Thoughts?
Cosine.
Cofunction. So instead of cosine, sine of chi, and in quadrant 1, positive. That's happy. We come over here. Sine, well, here it's pi minus chi. Quadrant 2, but it's based off of pi. That's x-axis. Same function. So I'm going to keep the sine of quadrant 2. Sine is positive, but I've already got a negative here. So the negative times the positive from the second quadrant remains negative. Making sense? Minus. Now I come over here. Oh! You know what? I don't know why it takes me so long to think of these things. Ah, yes. All right. So, class, we 3 pi over 2 minus, so it's based off the y-axis. So, cofunction. So, cosine of chi or chi. Quadrant 3 sine is, but I already got a negative. So, positive.
Why'd you say it like that one? It's positive.
He's trying to entertain himself, all right? As long as he's not overly distracting, that's okay. All right, next one, we got pi over 2. Class? Y-axis, so cofunction, so cosine of chi or chi. Quadrant 1 sine is positive, but I already got this negative, so negative. All right, positive times negative, class? Negative sine times sine. Negative sine squared chi. Come over here. Negative, positive, negative. Positive cosine times cosine. If only this were negative right here. What sine squared plus cosine squared would equal? 1. But it's not. It's negative sine squared plus cosine. Factor out a negative. Yeah, pull out the negative. What do we get?
Sine squared minus cosine squared.
Oh wait, that's not anything special either. I guess we're done. One could argue that factoring out the negative quote simplifies it, unquote. And there's our answer. Questions on that one? Feel like you're kind of figuring out what we're doing here. You want the quadrantal first. It's got to come first, but it's also got to be positive, so we may have to factor out negatives. This is about as ugly as it can get. Then, once the negative is factored out, if it's an even function like cosine or secant, negative vanishes. Odd function like most of them, negative comes out front. Then you can worry about what quadrant we're in. And then once you've done that, same function or cofunction, same function or cofunction, same function or cofunction, same function or cofunction as you do. But what about in this quadrant? What about in this quadrant? What about in this quadrant? Figure out the signs, SIGNs. Simplify as much as you can, and sometimes you're just mad because it doesn't simplify more than that. Questions on this? All right, have a wonderful rest of your day.